today's video. Oh, here we go. Right, we're on. Question 10 from FP1 January 2013. The sequence is defined by this, so it's just about subbing in numbers into sequence to start with. You've got U1 is 2, so U2 is U1 over 1 plus U1. So that's going to be 2 over 1 plus 2, which gives us 2/3. Now, we've got U2, but we still haven't found what we're looking for. Thanks. So U3 is going to be 2/3 over 1 plus 2/3, which gives us 2/3 over, if we turn them both into thirds, we've got 2/3 plus another 1 will be 5/3, wouldn't it? And then we can cancel out the thirds to leave us with 2/5. And then we sub that into the next one, so U4 is 2/5 over 1 plus 2/5, which is 2/5 over 7/5, because that's 5/5 plus another 2. So that gives us 2 over 7. And that was what we were supposed to get. It did say, show that U4 was 2 over 7. So that was quite straightforward. Part 2 hence suggests an expression where we spotted that if U2 was 2 over 3, U3 was 2 over 5, U4 was 2 over 7, we suspect that would mean that U5 would be 2 over 9, and so on. It's going up with the odd numbers. So the odd numbers are twice the term number. Take away 1. 2 3's take 1 gives us 5, 2 4's take 1 gives us 7, 2 2's take 1 gives us 3 there. So we're going to suggest that UN is, well, we've always got 2 on the top, and we've got twice the term number, take away 1 on the bottom. That's pretty crucial, because if you don't get that, if you don't spot that, then you're a bit stuck for going onwards. Yeah.
Did you not have to show any other working out?
No, that was it. It was only 1 mark.
Two.
Was it 2? Oh, you didn't have to show anything more than that. That would do it. Part 3 says, use induction to prove that your answer to part 2 is correct. Okay. Now you're going to get, even if your answer to part 2 is wrong, you're going to get some method marks if you follow through the method of proof by induction. So what do we have to do? We have to start with, what do we have to do first? N equals 1, or any suitable number. So if n equals 1, U1 would be 2 over 2 minus 1, which is 2 over 1, which is 2, which is what it was. So we've shown that it works for n equals 1. What do we do next in proof by induction?
Assume true for n equals
Assume it's true for n equals k. So we're going to assume for n equals k that UK is 2 over 2k minus 1. So that's stating our assumption. What do we need to do next? The standard steps. We need to
k plus 1.
Okay, we need to show that this then works, and we need to prove it for n equals k plus 1. Okay, now what we're heading towards here is if we give ourselves an idea where we're going, we would get 2 over 2 lots of k plus 1 minus 1. That's what we've got to end up showing. Now, of course, that is equal to 2 over 2k. What would that be? 2k plus 2 minus 1. So that would be that, wouldn't it? Is that right? So that's just giving us an idea about where we're heading towards if everything goes okay with this. Now, actually, if we're going to prove this for n equals k plus 1, we're going to look for u k plus 1. And from the initial statement at the start of the question, u k plus 1 is uk over 1 plus uk. And our assumption told us what uk was. Our assumption said that this was 2 over 2k minus 1, and this would be 1 plus 2 over 2k minus 1. Now this is all getting a bit messy with these fractions within fractions, but we need to try and simplify this. We're going to put the bottom line over common denominator. So just the bottom line there. We're going to write, leave the top as it is, we're going to write the bottom line as being 2k minus 1 over 2k minus 1 plus 2 over 2k minus 1. So tidying up that bottom line, we've got, still got that on the top, let's not worry about that. We've now got common denominator on the bottom of our fraction, and we've got 2k minus 1 plus 2, which is 2k plus 1, isn't it? Probably 2k minus 1, the bottom. Now, because they're both over the same denominator, these two fractions, we can ignore the denominator. This is 2 over 2k plus 1. Remember, that's what we were looking for. Let's, just to be absolutely clear on that, let's rewrite that as being 2 over 2 brackets k plus 1 minus 1 to show that we've got to where we want it to be. That's absolutely there. We now say, as it's true for n equals 1, and if true for n equals k, the result is true for n equals k plus 1. Hence, by induction, un is 2 over 2n minus 1 is true for all n greater than or equal to 1. And we have to have some kind of statement at the end of it to show that we've done it. That was it. I thought that was quite a nice ending for the paper, actually.